maybe not so much. And so in your notes here, a few fill in the blanks, a few things to point out. So terminology, the first term I want you guys to see here is the word relation. So a relation is simply a set of inputs and outputs. And that's kind of the first time we've used the terminology inputs and outputs. So input will always go with the letter or the variable x. Output will go with the variable y. So a relation is really simply a group of x comma y's. So a bunch of x, y's, points on a graph. A relation is just a group of those, right? A set of those. So we've dealt with those already quite a bit. We just didn't call them a relation. The other word up there is a little bit more important, and that's the word function. So a function is a relation where every x value, every input, has exactly, do you know the blank? One. One is correct. So exactly one output. Let me try that again.
3 or 1 or 2 or something like that.
What do you mean by 3 or 1 or 2?
Like it's always the same number for every.
No, it's talking about the number of outputs. It's not saying that the output is 1. It's saying that for every input there is exactly one output. The output could be 7 or negative 12 or 39 million or something like that. But the point is that for every input, there's only one output.
Well, yeah, that's what I'm saying.
Yeah. Now what the output is, that could be whatever, but we're talking about specifically one, exactly one. Not at least one or less than one, but exactly one. Okay. All right, so a couple of other terms here before we get started. The word domain. Have you ever heard of that? Domain? Okay, so the domain is the set of inputs, and inputs always goes with which variable? We said it goes with x. That's basically a listing of your x values, a listing of your inputs, you could say. And then the other word here is range. Range is a list of your outputs, also known as which variable?
Y.
Y. There you go. All right, so I think that if you take what we've just been talking about with relations and functions and more specifically domains and ranges, I think we can probably handle number 1. So if you guys would, take a look at number 1. I'll go ahead and scroll up to that. Okay, so please take just a minute here. Look at number 1. Number 1, you have what? 1, 2, 3, 4, 5. Yeah, 5 points there. 5 x comma y's. So the goal here would be with the domain to list out all the members of that domain. Same thing with the range. Okay? Take a minute, take pencil or pen to paper, write it down. I help you remember a little bit. Remember that domain goes with your inputs or your x's. Range goes with your outputs, also known as your y's. Okay? So please do take a minute and write that down. Yeah. Question, Braden. Yeah. Okay.
If it's not given G, how do you solve it?
If it's what did you get for your domain? So guys, there is Tay's domain. Do you guys agree with his domain?
Yeah.
Negative 4? Okay. Now do you agree with his domain?
Absolutely.
Absolutely. I agree. So Tay, how did you get to that answer? Like what were you really looking at? Yeah. All the x's, right? Yeah, definitely. You're right. And then if he listed all the x's for the domain, what would we use to give us the range?
Y.
All the y's. So your range would be 6, 4, 2, 9, and 3. Good start? Good start? Okay, awesome. Let's go ahead and take a look at number 2. Number 2 is focused on a little bit of a different topic, or a little bit of a different aspect to this. Number 2 is wanting us to determine whether each relation is a function, right? So let's remind ourselves, a function is any relation where every input has, not an output, but exactly one. Exactly one output. So these relations here are presented in various formattings. So like A, if you look at that, I would call a mapping. And with mappings, the left side is always the input or the x's. The outside is always the outputs or the y values. So I would ask you, in letter A, I want you to think about this for a second. Does letter A, with the the inputs on the left and the outputs on the right, does that represent a function? Does it follow the rule for functions, or is it not a function? So what do you guys think? Look it over. Feel free to respond once you think you have a thought. Basically, it's yes or no with a reason, right? Yes, it is a function, or no, it is not with some kind of reason. Braden, what'd you think?
Well, just for number A?
Yeah, just for A, basically yes or no with a reason.
Yes, it is a function.
So he says yes. What's your reasoning?
Because for every input, there's exactly one output.
Yeah, well said. Well said, right? Let's examine that a little bit closer. Do you guys see if you focus on the 7, do you see how the 7 maps to the 4? And that's it, right? The 7 has an output. It has exactly one output. So far it's definitely a function. 9 also has exactly one output, happens to be a 6. And then the 11 has exactly one output, and it's a 2. So for every single input, you got exactly one output, making it a function, just like Braden said. Does that make sense? Okay, so it's following that rule, so we say yes. Now go ahead and take a look at letter B. Let's see if you guys can handle this as well. Let's give everybody a chance to think about it. I know you've worked ahead a little bit. Let's give everybody at least like 15 seconds to think this through. Does B represent a function? The question is going to have an answer of yes or no. And Garrett, what do you say?
2 has an output of 3 and 1.
Did you notice what he just said there? See how the 2 has 2 different outputs?
Told you.
Yeah. So reasoning wise, you could say 2 has 2 outputs. Like you said, it's got an output of 1 and an output of 3. So 2 different outputs, making it not a function. Is this making sense? Let's go ahead and move on to C and D. Again, let's give everybody a chance to think this through. I know you guys have worked quickly. Let's give everybody a chance to come to their own conclusions. So with C and D, we're essentially saying yes or no, it is or it is not a function, and also have a reason based on what functions are and how they work with their inputs and their outputs. Just looking at C and D. Just a little heads up here. If things go, there's a question up there. Awesome. I was going to say if things go like they did in the other class, I think we'll end up with maybe 10, 12 minutes at the end of our class to do a few questions on web assigns or other general questions on things. So keep that in mind. So if you're thinking maybe you did have a question, you want to look it back up, maybe you could do that here during our class. Okay, so Brian, what do you think about C?
No.
Brian says no on C, and what's your reasoning on that, Brian?
If you look, all the X's are different, but the Y's are the same, so
So
the same output.
X's are different, Y's are the same. So all of the X's have the same output? Okay, so I'll say all
But they all
X's, I'm still talking, hold on, have same input. Okay, so reactions to that, Spence, what was your reaction again?
They all have exactly one output.
Okay, so he's disagreeing. What do you guys say?
I disagree too. I disagree.
Disagree with Spence
No,
or
I
disagree with
disagree.
Brian? Disagree with Brian. And did you have the same reasoning as Spence?
Yep, yep.
Okay, well, let's go ahead and think this through. So they're all saying yes, right? So maybe another way to look at this would be to look at this like a mapping. So let me try to translate this over to a mapping. So here's my domain, my inputs. My inputs would be 0, 3, 4, and 9. And what is my only output?
8.
8, yeah. So doesn't the 0 map to the 8? And the 3 maps to the 8, the 4 and the 9, they all map to the 8, don't they? Do you see that represented with that mapping there? And so let's think this through. The definition of a function is a relation where every input has exactly one output. How many outputs does the 0 have?
1.
1. What about the 3?
1.
The 4 and the 9?
1.
It is a function, isn't it? Does
Yeah.
that make sense? Yeah, so we would say, yes, it is a function. The reasoning would be because every single input has exactly one output. And you're right. The outputs are all the same output, but that's okay. On a graph, can you guys think about what this might look like on a graph?
Yeah, it'd be like
Yes.
a vertical line.
No.
What?
It would be different.
It would be horizontal, whoever said that. This would be a horizontal line because it doesn't really matter what the x values are. Aren't the y values all 8? So I think it would be all y values of 8, regardless of what the x's are, all the y values are 8, which is a horizontal pattern. There was a question. Sorry, did I get it answered? Oh, Haley, you had your hand up.
That was for D.
For D, okay. Well, let's hear it. What do you think for D, Haley?
It's not a function because 4 can be 6 or 11.
Yeah, -4 maps to 2 different outputs, doesn't it? -4 does not have exactly one output. It's got 2 outputs. So -4 is the one that disqualifies this from being a function. So you could say no because -4 has 2 outputs, and that would be a good reason for saying it's not a function. Question, Garrett.
Did I miss something, or did you just say it would be a horizontal line?
For C?
Yeah.
C, yeah, at least it'd be a horizontal pattern.
Why wouldn't it be vertical? It's like
We could just plot the points if you wanted to. Check this out. So this will be,
Oh, no, you're right. I'm sorry.
it's okay. Every now and then I mess up too, right? So it's at least worth questioning. So yeah, you'd see, 0, 8, 3, 8, 4, 8. All the y values are 8. So it should be a flat horizontal line like that. Okay, good thoughts? Other questions? Anything I can follow up with you? All right, you're doing really, really well picking this stuff up. The next thing we're going to cover here is function notation. This might be where maybe some of you have not seen this before, so please don't be shy about asking questions if you. And a parentheses and an X. Have you seen this before? Maybe I'm just curious. I mean, some of you probably have, some of you haven't. You have seen it before. Okay, so let me ask you this. Can anybody tell me how, come on, there we go. Can anybody tell me how you read this notation? The F parentheses X. How do you say that? Go ahead.
F of X.
It's F of X, right? It's not Fx or F times X, definitely not. It is F of X. F of X. There we go. So, in the recent past, like this whole year really, and more specifically in the last 2-3 weeks, haven't we seen a lot of stuff like this? What kind of an equation is that, by the way? Say again? The slope-intercept, meaning that if we graphed it, it would be what kind of a graph? It would be linear, right? It would be a straight line, and you identified it as slope-intercept. So, just for fun, what is the slope on this particular line? 3 is the slope, yep. And the y-intercept then is? -4. Oops. Y-intercept, there we go. All right, so we've seen stuff like that regularly. In fact, we've created tables of solutions. We plugged numbers in for x, like inputs and outputs and all that stuff. And so if y equals f of x, if y is a function of x, then we will now see, every now and then, we'll see equations like this. And I want to talk about what these different parts of this mean. So f, the letter f is the, what would you say f is? Go ahead, Matt.
I thought FX was like Y.
F of x does function the same as y. You can see that right here. Y and f of x do have the same role. But I would say that f, like what would you describe it?
Output.
I would say that f of x in a whole is the output, right? But just only the letter f.
The y-intercept?
No, x is the input, right? X is always the input. So I'm just referring to letter f. It's way simpler than you guys are making it. I would say that f is simply the name of the function. It's what the function's named. We want to be able to have f of x or g of x or h of x. It's just like you were not named, I mean, I hope you weren't named this originally, person. Or maybe human, right? Wouldn't that be weird if someone had a baby, they're like, let's name him human. It's not a very unique name. I guess it is sort of a unique name, right? But it's just calling you what you are, right? So they gave you a name, like Garrett starts with G, right? So we might have a function called g of x, right? John starts with j, there could be a j of x function. It's simply the name of the function. That's it. So the x, we talked about this earlier, what Joel just said. The x is the input. And then 3x minus 4, that whole thing would be the output for the function, right? As you evaluate the right-hand side, 3x minus 4 is the output. So f of x equaling 3x minus 4 is really a similar notation to y equals 3x minus 4. We're just allowed to see more things with functional notation. Yes?
So in that one, the 3x is the slope, and then the y-intercept
No, the 3 is the slope.
Yeah, the 3 is the slope, and then the -4 is still a y-intercept?
Yep.
So,
But the whole thing is the output.
okay.
The whole thing is the output there. Okay, so we're going to work with these functions here. I'm going to do one or two of them with you, and we'll see if you guys can handle the rest. Is to think that f of x really means f times x. It's not at all what it means. It simply means that x is the input, and the name of the function is f. But it is definitely, I hope you're hearing me, it is definitely not f times x, right? It's just not what it means. All right, so I'm going to do this first example with you, and I'll let you guys work on the other parts on your own. Maybe the other. Maybe we'll do two. We'll see how it goes. All right, so f of 3. Here's what we would do with f of 3. We've got this function up here. The function is f of x equals -5x plus 7. So for f of 3, all that's really telling me is that my input is 3. So I will replace any x's that I see with a 3. So it'll look like this. F of 3 equals -5 times 3 plus 7. So you see what I've done there? Just replace the x with a 3. And I'll just do a little bit of order of operations on the right-hand side. Do the multiplication first. So -5 times 3 is -15. Then I add 7. I'll just come up here. I get f of 3 equals negative 8.
What does negative 8 stand for?
Great question. So what this is saying that the input is 3. And the output is 8.
But isn't f of 3 the output?
And it's equal to 8, isn't it?
Oh, I see.
See what I'm saying? It's two different ways of looking at it. Here's another way to look at it. When x is 3, y is negative 8. When x is 3, y is negative 8. Let me show you one other way to say this. If x is 3 means that y equals negative 8, couldn't we also write this like this? Isn't that the same thing? X comma y. When x is 3, y is negative 8. So this function notation is really just another way of writing a point on a graph as well. Okay, so at that point I've got my input, my output. My input is 3, my output is negative 8, and I would be done. Braden, question.
If on the test you put just f equals negative 8, that'd be wrong, right? Instead of
Yeah,
f
because
three.
it's f is not equal to that. F of 3 is. Yeah. All right, let's see if you guys can handle the other two. F of negative 9 and f of 0. There we go. So instead of f of negative 8, it really should say g of negative 8. So I'll try to get rid of that little typo there. There we go. All right, so this is quite similar to what we just did. Different functions, different inputs, perhaps some different outputs. So again, I think we can just look at this a little bit of practice right here, right? So take a minute, see if you can figure out what these two evaluations are, and then we'll double check. For letter A, what did that look like for you?
Okay, so the first g of negative 8 equals 1 minus 6 and then negative 8.
So what do you mean by and then?
Like for,
Oh, in parentheses, okay.
sorry.
Okay, keep going.
So and then g of negative 8 equals 49. Negative 6 times negative 8.
Right.
And
So,
then plus 1 is 49.
okay.
Wait, hold on, I lost my.
So g of negative 8 equals 49.
Yeah, and then g of negative 8 equals 49. So then it's negative 8, comma 49.
Okay, yeah, so I want to reiterate, you don't have to go to this place that you did at the end. You don't have to go there.
Okay.
Definitely don't. I just wanted to show you that you could. If you were going to graph it, you could certainly do that, but you don't have to.
Okay.
Okay, so John has done an excellent job, giving us a good example there. Do you guys agree? Questions? Yeah, Brian. So we're okay? Okay. So then B. B is very similar. It holds its own set of challenges. Brian, do you think you've got this? What do you got?
Alright, so you plug in negative 3 for all the x.
So would you tell me exactly what to write?
Okay.
Because the way you write it could make a difference.
H times
No.
h of negative 3
There you go.
equals negative 3 cubed minus negative 3 squared plus 8.
Let's just pause right there. What do you guys think of that notation? Good or bad? Not good.
Not good.
Not good. Can I add some stuff in here that would make it good notation? What would it be?
Would you just plug into the regular x because
Well, hold on. What do you mean by the regular x?
the one with the numbers above it.
I'm not. What numbers above what?
The letters x.
The exponent.
Like x cubed, x squared.
Plug. Okay, now I'm lost. Plug what in for what?
Negative 3 and just the x.
That's what we did though.
No, but like not the x.
You're saying you
cubed,
would
x squared.
subtract x to the third minus x to the second.
Is that what you're saying?
Yeah, because
Those are not like terms though.
you can't do that.
You can't add or subtract like unlike terms. You can't do that. Emma, what do you think? What could we do to this to make it better notation?
Wait, you put parentheses?
Yes, you've got to use parentheses here. Let me erase this and show you where I was going with it. Do you remember way back when we started doing evaluations, I suggested to you that if you're going to do some plugins, that you replace any variables with an empty set of parentheses. That's what we're doing here. This would make a pretty big difference. So empty parentheses cubed minus empty parentheses squared plus 8. So Emma, you've got it exactly right. We've got to have these parentheses in here. And then inside the parentheses is where you put your negative 3. So negative 3 here, negative 3 there. Okay. Definitely want parentheses here. Peyton, can you help us out? Brian has gotten us started off. Emma got the parentheses in there. What is negative 3 in the parentheses cubed?
Negative 27.
Nice.
And
Okay.
then the negative 3 squared is 9.
So tell me exactly what to write after the negative 27.
So plus 9, or minus 9.
He's right.
The negative is on the outside.
It's minus 9. And then, of course, plus 8, right? So let's stop right there. Peyton is definitely correct. Do you agree? You see why it would be minus 9? A lot of folks maybe would be tempted to put plus 9, right? Order of operations, you need to do the exponents first, and then you do multiplication division. To make it a plus minus would be actually flipping around the order of ops at that step. So be very careful. Any questions? Can I work that out in more detail for anybody? Okay. So once we get to here, it's a matter of adding up our like terms, adding up these integers here. So negative 27 minus 9 is negative 36, and then plus 8 gives us, did you get it? Negative 28?
Yep.
Okay, very good. So we've gotten in some pretty good repetition. We got 5 repetitions with those in there. Are there any follow-up questions that I can do before we move on to kind of our final little topic here? Do it okay? All right, fair enough. Let's take you good? You're good? Okay, let's take a look at our next little bit here. When you look at a problem like number 5, it says graph g of x equals 3x minus 2. I want to remind you that earlier I told you that y equaled f of x. So what I was trying to get across to you there is that y has the same role as f of x. They're both outputs. So when you look at this with number 5, you really could think of it, if you wanted to, as y equals 3x minus 2. What kind of an equation is y equals 3x minus 2? It's linear. What kind of a form is this in right now? Slope intercept. Yeah, so Jay, what's the slope?
3.
Slope is 3. What's the y-intercept? So Jay, when you're graphing these with slope-intercept form, do you start by graphing the y-intercept or the slope? The y-intercept, that's right. So if you guys would, this is good review for your quiz on Monday, really. So if you could, graph the y-intercept, count off the slope, and let's see if we can get this line set up. And then we're going to look at number 6, which is a totally different graph. I would bet many of you have never even seen number 6. Nope, it's not a parabola. Just a reminder to you all, if you're going to graph this, your y-intercept is negative 2, just like what Jay said, we would graph that first. So there's that. Please remember that if you're going to use slope, I want to see your little slope triangles, your rise and your run. So if you're going to rise 3, I want to see like a little dotted line, rise 3, run 1. And maybe you do 2 of them if you want, rise 3, run 1. And then you put your points there. But I will be looking for your little slope triangles. The reason is I want to see evidence that you know what slope is, you're counting it off correctly. So like having your little slope triangles on your graph, that would be assigned a point on your quiz. I will be looking for that. So if you have it on there, I'll see it. I'll be trying really hard to see your slope triangle. Please don't forget to put it, okay? It's worth a point. It would maybe be frustrating to not get that point. So please do those slope triangles. Then you do your best to connect the dots with a straight line. Not the straightest line I've ever drawn, but I'm just going to leave it as is. All right, any questions? All right, I'm excited about number 6. Like I said, I don't know that you guys have ever seen number 6 before, so check it out. Okay, so what's with the bars on number 6? It says f of x equals these bars. What are they? Absolute value. That's right. So let's remember a little bit about absolute value. Regardless of the input, right? Whether I plug in a positive number, a 0, a negative number, a fraction, a decimal, whatever I plug in for x, what is guaranteed going to come out for the output?
A positive number.
A non-negative, right?
Yes.
A non-negative number will come out as an output.
Oh, because it's 0.
0, yeah. The output for 0 is 0. Yeah. So all positive numbers and the 0 would be possible here. So I want to make a little table of solutions and look for some suggestions from you guys as to what numbers we ought to plug in. So I've got x's, I've got f of x equals absolute value of x. What do you all think as far as some smart inputs? What would you plug in for x to get a sense of this? Yeah, go ahead, Brian.
-2.
Okay, -2. So if you plug in a -2 for x, you do the absolute value of it, what's the output?
2.
2. All right, so my first point would be -2, comma 2. I'm going to go ahead and plot that over here. So -2, comma 2 is right about there. There we go. All right, how about another input? What do you think, Garrett?
How about 0?
How about 0? I like that. What if you plug in a 0? What's the absolute value of 0?
0.
0.
Yep, so there's another point. So the next one would be 0, 0. It's right here at the origin. There we go. Suggestions for another input? 2 or 1? Sure, let's do both of those. So there's a 2, there's a 1. What's the output for 2?
2.
And what's the output for 1? 1. So 2, 2, and 1, 1. So let's see here. 2, 2 is right here. 1, 1 is right there. This is interesting. Has anybody figured out the shape of this yet?
The V.
It's a V, or maybe the end of an arrow. Sure. So it's very linear over here, right? It's a straight line right there. But then it's also a straight line over here. You could plot a bunch of points to see that. And then right there at 0, right there at the origin, it makes an abrupt turn like this. This one actually makes a right angle and bounces up and heads back up. So look at all the y values on our graph. Are there any negative y values?
No.
Because negative y values would show up where?
It'd be impossible.
Well, instead of it being possible, where do negative y values show up?
Below the
In-
x-axis.
Below the x-axis. Do you see any points below the x-axis?
No.
Doesn't that agree with the idea that we're doing the absolute value of any inputs? Right? The absolute value would create all non-negative outputs. Okay, so just a quick glimpse there at the function absolute value of x. All right, we got 2 more things to talk about here, and then we'll be done. They should go by pretty quick for you. Vertical line test. Take your arm, please, and make a vertical line. Take your arm and make a vertical line. It looks like you're asking a question, right? Straight up in the air, vertical line like this. So the idea of the vertical line test is written right here. If a vertical line passes over a graph, and if that vertical line intersects a graph in more than one point ever, then the graph is not a function. The graph is not a function. So to do something like this, the age-old method is to take your pencil, your pen, your finger even, make a vertical line with your pen or pencil, right? Make a vertical line like this, and then just pass it from left to right over the graph, okay? And as you pass that vertical line, as you pass it over the graph, if it ever intersects more than one point, then that graph is not a function. But as you pass that vertical line over there, if it only ever just intersects just a single point at a time, then it is a function. So vertical line test. If I pass this vertical line test over these graphs, if I ever intersect more than one point, not a function. If I just intersect one point, then it is a function. So you can make a pretty quick judgment on these, right? This shouldn't take too long once you get the idea of the vertical line test. Does that make sense? Charlotte, do you think you have some answers to this? So in other words, like with A, with graph A, do you think graph A is a function or not?
Yes, 'cause is it? Well, can't if you had a pencil and you took it over like horizontally, couldn't you find like a? I'm so confused.
No, it's okay. Hold on. So there's a vertical line, right?
Yeah.
So if I take that vertical line and I pass it over the graph, like I move it from left to right,
Yeah.
would that vertical line ever intersect graph A in more than one point?
Yeah. It could. I feel like it could intersect anywhere if it wanted to.
Well, but it has to be a vertical line, though. Do you see how, when I put it right there, do you see how it intersects the graph in 2 points?
Yeah.
And wouldn't that be true pretty much all the way across the graph?
Exactly.
So, if that vertical line ever intersects the graph in more than one point, not a function. So for A, we would say not a function. I'll just put not a func. Okay, so Charlotte, does that make sense?
Yeah.
Reasoning there? Okay, good deal. All right. I hope that was a good explanation for everybody here. Haley, what do you think about B? Do you think, based on the vertical line test, do you think B is a function, yes or no?
Yeah.
Yes, it is. I agree with you, right? So as you take that vertical line, as you move that vertical line across the graph, isn't it going to only intersect one point at a time? So I would say B is, yes, it is a function. Yes, it is a function. And then for C, Andrew, what do you think about that one? Vertical line test tells us,
Oh, I say no.
why do you say no, Andrew?
Just kidding, yes. No, it's no way. Just kidding again, yes. No, it's no. No.
Sounds like a coin flip at this point, right?
I think it's a no.
You think it's a no?
Because it intersects the entire line.
Yeah, that's right. So as you take that vertical line and as you pass it across the graph, isn't it going to touch no points at all until it gets to the line? It doesn't touch any points at all. Then when it gets to that pink line, doesn't it intersect all of them at the same time?
Yes.
All of them sounds like a little bit more than one, right? It's infinitely many. And so the answer for C is not a function based on the vertical line test. So again, I just suggest, like I'm thinking of you doing your quiz on Monday, your test later on. I see you just taking your pen or pencil and going like this. Did it ever touch more than 1 point? And then make your judgment. Seriously, that's it. It should be really, really simple. Please don't overcomplicate that at all. All right, so our final function example for the day is number 8. All right, I'll read it out loud. You read along with me. It says, the function c of h equals 40 plus 5, parentheses h minus 2. This gives the cost in dollars to rent a cotton candy machine for h hours. Find the cost of renting the machine for 24 hours. So think about what you might need to do, just a little application. We've done questions like this before, but it has not been presented in function notation. So please take just a second here and get this finished up. For that one,
24 for 8.
good. So C of 24 is equal to 5 times 24 minus 2. Essentially what you said is great, right? Anywhere you see an H, put a 24.
You forgot the 40.
Oh man, I totally forgot the 40. Oops, let's try that again. 40 plus 5 times 24 minus 2. You guys are sharp for a Friday almost lunchtime. Nice work. I'm clearly running out of energy, right?
And then after that,
You could distribute or you could do order of ops. Why not just do order of ops? What's 24 minus 2?
22.
So you could just say C of 24 equals 40 plus 5 times, I forgot my 5. 5 times 22, right?
but you can do it either way.
You can do it either way. Yep. So 5 times 22 is 110. So I think our final answer would be C of 24 is equal to 150. What would be the units on the 150? Dollars. Yep. $150 to rent this machine for 24 hours. Okay, so ladies and gentlemen, that is it for our class, this new stuff here. We'll go ahead and do some questions now. So